I've been using them for a while, but I tweak them every year. Just to show you, I didn't finish this from last lesson, this notion that, Kayla, we can do an awful lot with direction now that we know how to add two vectors. For example, an object is initially moving at 6 meters. You know what? I'm going to draw compass rose. It accelerates due south at 3 meters per second squared for 4 seconds. Find V final. You remember this equation, Ty, from last year, Vf equals Vi plus At. It is a vector equation, which means it does work even if your directions are not in line with each other, as long as you follow vector math. So it says, I find V final, I'm going to go Vi vector plus At vector. Hey, James, what's the initial velocity, magnitude, and direction in this question?
6 meters.
Okay. Plus. Now here I have vector times scalar. I have 4 seconds times 3 south. You ready for how you multiply a scalar times a vector? You just first of all do the math. 3 times 4 is still south, because that's where the direction comes from. So my second acceleration vector is going to be south, 12 long. Should be about twice as long as the 6. I don't know if I quite got that right. Now, how would I add those together? It's going to be 6, 12, and this is a little weird. V final would be that vector. Theta would be up there. You would do the Pythagoras, and then you would do shift tan, and you could get the however many degrees what of what, and I think it would be solve it. And in fact, I'm not going to test or in the homework. This is just kind of a, you know what, might be in the homework. I can't remember, but this is trivia. Hey, we can handle stuff like this now. What I really want to get to is today's lesson, lesson 3, applications of vectors. The famous river problem. The two best applications of vectors, going across a river when there's a current, or flying a plane when there's a crosswind. Mathematically, same thing. Okay? Says this, an observer is standing on the shore of a river. He sees a boat traveling across the river. The boat's velocity Let's draw a little picture. Here's the river. Is that okay? He sees the, let's decide that the current is going this way. You could have it go the other way, but just so the question doesn't say. If it said, we'd do the correct direction. If the current is moving to the right, which way is the boat getting pushed? To the right. So it says the velocity on the river is 8 meters per second. I guess it would be like this, with an angle of 65 degrees with the shore. That's the resultant. How fast is the current? That out. Yeah. I'm looking for a word that begins with letter C and rhymes with Hey, I can take and I can break it up. I think I can break it up if I draw it here. 8, where that means something and that means something. In fact, if I hear you arguing, that right there is the current. Now you have to use your imagination. The boat itself by the... Okay. Connor, keep going. That 8, opposite, adjacent, or hypotenuse. What about the current? Which trig function? Of course it is. Cool. So I have cosine 5 equals current over 8. I guess the current is going to be, how would I get the current by itself? What would I do with that 8? Okay, I'm not even going to write that. I'm going to go straight to my calculator. If you want to write it, you can. But cos 65. Looks like this current is 3.38 meters per second. Okay. Moving across the river. Which velocity is that one? The vertical. The vertical. Okay. That's going to be this one. Okay. Max, that one, opposite, adjacent, or hypotenuse. Which trig function? I'll use the 8 this time. Sine of 65 equals v over 8. How would I get the v by itself, Max?
I'd
7.25? Meters per second. Is that okay?
Yeah.
What's B want me to find? Sorry, C. What's C want me to find? Oh. Now, for these questions in Physics 12, both for airplane, crosswind, and river, we're going to assume that. I could, if I wanted to, also throw an acceleration and forget it. And what that means then is I can use this. Distance equals velocity. Displacement equals velocity times time. It's d equals vit plus a half at squared, but no a. So no a half at squared. What did you just want me to find? Okay. You know what? Let's go draw a little picture here. I guess that 256 is this distance here. Let's add that to our diagram. Yeah. How would I get the t by itself here, Connor? So if I hear you correctly, you're telling me time is going to be d over v. What's the d?
The 256.
Yep. And here's the magic question. The problem is, I seem to have 3.8. I got a 3.38, and I got a 7.25. Why would it not be the 8? Yeah. Even more basic than that, why can't you use the 8 in this equation? Yeah. Yeah. The directions don't match. What direction is your distance? Dead vertical? What direction should the velocity that you use be? Dead vertical. That's by far the most common mistake on these river questions, using the wrong velocity. And so I'm going to say to you, James, direction, 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 direction. Which velocity am I going to use? I'm going to use the dead vertical one, which in this case was the... More specific? More specific as a number? And that's really the whole theme of today. Please make sure, however you draw your picture, however you dope, make sure if you're calculating something from the picture that the directions match. 256 divided. I'm going to use my answer button because I have the 7.250 still set on my calculator. 35.3 seconds. Even though time is a scalar, it's coming from dividing two vectors. The directions have to be identical so that your directions cancel. That's not quite right mathematically, but you can think of it that way if you want, as a way to remember. D. How far down the bank will the boat have moved when it reaches the far side? You know what? I think now this part is asking me if the boat starts here to find this distance. In fact, I'll even call it a D. How can I find that? I think I can start here again. D equals VT. Except I'm going to argue, if I'm going to be consistent, Robbie, if I'm calling that dx, which v should I use? Which is the horizontal velocity in my diagram? Current, right? Current. Yeah, which is 3 point whatever. Yeah, current. Okay? Direction matters. Time, well, which time am I going to use? The amount of time it takes him to go across is the same as the amount of time he's going to drift down. Right? So, it's going to end up being, what was Vx? 3.38? Time was 35.3. How far downstream will this boat have drifted? About 119 meters. Yep.
Is it okay if you do it another way?
What?
You take like the 256
Uh-huh.
and then you come to 65 degrees. Then you can do tangent 65 equals 256.
I think that'll get there too, yes? Mine's quicker. Just saying. Yep. E. What's the boat's engine velocity? I'm going to give you a hint. You don't need to do any calculations or math. You know it already. I think what's pushing it across is the 7.25. The 8 is the combination of the current and the engine. It's the resultant. I think, by the way, that's why I left the V blank here. If you really wanted to, you could put a VE for engine, VE for engine. I left that blank on purpose, but I'm pretty sure V engine is going to be 7.25 meters per second. Let's suppose that's as fast WOT, wide open throttle. Okay? Just so that we have some consistency, here's a more interesting question. Let's suppose you're going to go wide open throttle, you're going to go at 7.25 meters per second, but instead of ending up 120 meters downstream, what if you want to end up straight across? What direction will you have to point the boat if you want it to travel in a straight line across? I think into the current. Yes? I think you're going to have to point the boat, don't write this down, but you're going to have to point the boat kind of that way. And it's going to go straight across. It'll look kind of funny from the shore, but it'll work. So I'm going to argue that we need to point the boat this way. I'm not quite sure what angle it's going to be, but I can tell you how fast we're going, 7.25 meters per second. He's flooring it. I don't care. See, as soon as you, well, if he's going against, now you're talking about the resultant. I'm telling you, relative to the boat, it's 7.25 meters per second because that's what the engine's putting out. Relative to the shore, they'll see something different because there's a current and all sorts of other stuff involved. We want to combine that with the current. Well, the current was 3.38. I'm going from memory, but that's what it was, yes? I'd like to add those two vectors together. Any thoughts on how I want to do that? Now here's the beauty. Watch. If I add these tip to tail, I know what the resultant is supposed to look like. Now this time the resultant is not a hypotenuse. This is brand new. But I know what it's supposed to look like. The resultant is supposed to look like straight up. Oh, don't draw the current that long because that doesn't give me a resultant straight up. I know don't draw the current that short because that doesn't give me a resultant straight up. If I want this diagram to be roughly to scale, tell me when I should stop drawing the current. Right there. The current is 3.38, and this, not a hypotenuse this time. Although, thankfully, James, still a nice, lovely right angle. I can find it. How can I find the magnitude? Oh, so the first part asked what direction. The direction is going to be that theta right there. And if we put a compass on here, that theta right there, north of south, east of west, what of what? Start out going north and then go west of north. So theta is going to be west of north. I'll leave a spot for the angle. Which trig function to find it this time? Not tangent. This is why I said it's going to be usually tangent. That 3.38, opposite, adjacent, or hypotenuse? Opposite. That 7.25. Hypotenuse. Which trig function? Excuse me. Apologies to those of you on YouTube if I coughed into your headphones. Although, if they're new to me, they don't know that I yell all the time, and so I guess I shouldn't bother apologizing. I'll apologize after I do one of my yells, yes? 27.9 degrees? Yeah? Is that right? Or am I wrong? Connor, you're looking at me. Am I wrong?
No, I was just expecting something else.
Oh. Okay, now, the other thing that might happen will give you that angle there. Well, that angle there would be 90 minus this, and then they would say 62 degrees with respect to the shore. And that way they could avoid bringing in north, south, east, west. They would just say, oh, whichever way the shore is, angle 62 degrees away from it. Question, what will the resultant vertical velocity be? I can tell you its direction, 27.9 degrees west of north. What about its magnitude? How can I find that? It's Pythagoras, but I have to be careful because I'm not finding a hypotenuse. I think it's going to end up becoming 7.25 squared plus mystery velocity squared equals, sorry, let's try that again, Mr. Duick. I botched that totally. 3.38 squared plus mystery velocity squared equals hypotenuse squared. Drake, how would I get the VR squared by itself? What will I do with that 3.38 squared? Yeah. Aren't you glad I pushed you guys into this whole formula manipulation thing last year? It's so much easier. 7.25, let's try that again. 7.25 squared, 3.38 squared, and then square root. 6.41 meters per second. Not at 27.9 degrees west of north. My resultant vertical velocity would be due north. Yes, did I screw up somewhere?
No, I was just
Yeah.
asking about the angles. If the boat is getting launched 65 or
62.
the resultant is 65.
62, isn't it?
Is it?
62.2 degrees. Sorry, the resultant is due north. I got to be fussy.
Of
The resultant is due north.
The first part of the question.
Okay, so which way are we pointing the boat initially? Yes?
North.
No.
Wait, what?
He's talking about before. I can't.
Oh, are you talking about part A?
Yeah.
Oh. Okay, sorry. Yeah.
So why wouldn't launching the boat 65 degrees the other way put you due north?
It would be close. It'd be close. The answer is because I need to add some more information in this question so that you can clearly see that he's going downstream. I didn't make this question clear enough. Like I should have said, if the current is moving east, assume he's pointing at 65 degrees north of east, and then you would draw it that way.
Okay.
If he pointed it at 65 degrees into the current, he'd almost go bang. And by the way, in real life, that's what you do. You eyeball it. Nobody sits down with a calculator. Okay. Hey, how long with this new method, by the way, going straight across, is this going to be faster or slower to get across? How long would it take? Well, what was the distance across? 256 divided by, and now I can use the 6.41 because that is in the straight across direction. 6.41. It works. 39.9 seconds. What was the other time?
35.3.
Only a little bit longer, but he saves himself walking 120 meters to get back to where he wanted to go. Probably do it this way. Handy hint then, if they give you a horizontal distance, a vertical distance, dy, make sure you use vy, make sure your directions match in the river questions and in the airplane questions. Rarely will you use the slanty to find a time or a distance. Rarely. Example 2. Example 2 is a repeat of example 1. I just changed the numbers. An observer is standing on the shore of the river. He sees a boat traveling across the river. The boat's velocity in the river is 12 meters per second, 55 degrees with respect to the shore. Let's assume he's going with the current. So if we DULP, we have the boat pointing this way. Sorry. Yes, the boat's velocity is this way. This is what the observer sees. 12 meters per second, 55 degrees with respect to the shore. Ty, what's part A you want me to find? I'm going to argue that this 12 is made up of that and that. I'm looking for a word that begins with letter C and rhymes with components. Components. Okay? And I'm going to argue, I'm going to say here is the current pushing to the right, so that there is the current. Oh, let's put the 55 degrees in, Mr. Duke. And this here is the velocity of the engine. The engine, that's an E. The engine is pushing it straight up. The current is pushing it to the right. And the resultant we get is a slanty, a hypotenuse. Hey, Riley, that 12 opposite adjacent or hypotenuse. What about VC, current? What about VE? Hey, which trig function am I going to use to find the current? I'm going to cut corners because I want to give you time to work on in class. So I think it's going to end up being, the current is going to end up being 12 cos 55. If you've done the homework, you've noticed these patterns are appearing fairly often, yeah? 12 cos 55. 6.882, I'll go 6.88. This river's a little faster. How fast is the boat moving across the river? I think that's the velocity of the engine. I think that's going to be sine. I think the velocity of the engine is going to be 12 sine 55. This engine is going at 9.83 meters per second. Find the time to cross the river. Make sure your directions line up. So I'll go back to my picture. Looks like this distance is this distance here, and it is 320 meters wide. I could even call that a dy. I could make it vertical in my picture if I wanted to. By the way, Drake, I drew my river sideways. Nothing would prevent you, Tori, from doing your river vertical. You'll get all the same answers as us. Distance equals VT equals D over V. 320 divided by 12? No, don't use the slanty. What is in the same direction as the 320? The 9.83. 320 divided by answer button. Haha. And I get 32.553, 32.6 seconds. Is that okay, Kayla? Pretty repetitive now. How far down the bank? Now they want us to find a distance. That's going to be velocity times time. But since the distance is horizontal down the bank, I better make sure that I use a horizontal velocity in the equation as well. So horizontal velocity, that's the current. 6.88. Times 32.6. About 224 meters downstream. And yes, you could also do it using some trig with the distances as well, because they're similar triangles. But I think mine's faster. By the way, in 21 years, you're the first person to spot that, so candy for you later. Nice. Oh, what's the boat's engine velocity? We've already done it. That's what's pushing him across the river, which was 9.83. And now I'll slow down. What if you want the boat to land directly across from its starting point? I think you're going to point the boat that way into the current. How fast will it be going in that direction? 9.83. And then the current is going to be pushing it. What was the current? The current was faster, 6.88. I gotta be honest, I could not do this question if I didn't know what the resultant is supposed to look like. I know that the resultant is supposed to line relative to the shore. They want to go straight up. If they didn't tell me that, James, I wouldn't know how to draw this triangle. I couldn't solve it. But because they've told me that, I can go 9.83, add it tip to tail to the current, and I know to stop drawing. Right there. There's the 6.88. And the resultant is right there. I can get the direction from that theta. It's not tangent. Opposite hypotenuse. Sine of theta. Six point eight 6.88 divided by 9.83. Apparently I want to go, almost bang on 45 degrees. Not quite. 44.4 degrees. and that is west of north. By the way, Connor, I think it was you that, or someone was, I think it was Duncan that was asking. On a quiz, I would give you in the question way more direction. I threw these together. In other words, the question itself, I would tell you whether to draw the river north, south, or east, west. You wouldn't have to guess. Okay. What will the resultant vertical velocity be? Well, VR squared plus 6.88 squared equals 9.83 squared. It's going to be 9.83 squared minus 6.88 squared, square root, 7.02 meters per second. Due north. Your homework, I think that will get you through some of those weird ones on vector sheet B. And try these 3 questions. And then I have a nerdy cool video.